Since Lesson 31, we've been learning how to download and parse online JSON data. Also, we learned to turn that data into a local weather report on the OLED display with animated icons and a high, medium, low RGB temperature indicator. In the last lesson, we learned to convert HSV color wheel degrees into RGB values, which could be displayed on an RGB LED. Paul also introduced the idea of transferring frequently used code into a Pico library for easy access across various projects. Our assignment in Lesson 34 is to pull all this material together by adding the HSV to RGB logic to the weather report so that the RGB LED will change colors smoothly over the range of HSV colors from 40 HSV degrees to 360 HSV degrees as the local temperature changes from -30 degrees C to +50. Below we see the same diagram that we used in Lesson 33. This diagram describes the HSV color wheel in terms of RG and B color curves. This diagram helped us calculate the slope and y-intercept values which we used to convert the HSV degrees into RGB values between 0 and 1. But our Lesson 34 assignment is to calculate RG and B values based on current local temperature, not HSV degrees. In some sense, the simplest solution would be to change the horizontal axis of the chart from HSV degrees to local temperature degrees and recalculate a new set of slope and y-intercept parameters. But these new parameters would completely negate the benefit of having the HSV to RGB library function that we created in the last lesson. Another solution would be to create a new equation to convert local temperature degrees into HSV degrees. In that way, we could feed local temperature into the new equation and send the result of that conversion, which would be HSV degrees, to the existing HSV to RGB library function. The new equation could be a straight line conversion of temperature to HSV degrees. As we've done many times before, we calculate m, the slope of the line, as shown above. Once we know m, we calculate b. So our equation to convert temperature degrees into HSV degrees, y equals mx plus b, or HSV degrees equals 4 times the temperature plus 150. Let's add that equation to the weather report program. This program is fundamentally the same as the program used in Lesson 33. For the sake of brevity, I'll only highlight the differences here. See the Lesson 33 homework assignment for a description of the rest of the program. There's a link in the description. This program has additional imports. We import HSV degrees to RGB value, which is a function we developed in Lesson 33. It is now saved in the BK's function library. We import PWM because this program uses PWM to control the RGB LEDs. Here we declare which pin will control which color of the RGB LED. We declare our PWM objects, we set the frequency for each LED, and we turn each LED off. Here's where we declare the M and B parameters for our temperature to HSV degrees conversion. This new section of code converts the local temperature into HSV degrees. It then uses the HSV degree to RGB value function to convert HSV degree to RGB values. The RGB values are then multiplied by 65,535 to put them in the correct range for PWM use. Don't forget to apply the int function though, because the RGB values coming out of the HSV degree to RGB value function can be floating point. That's all there is to it. Here's how it looks. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.